Now let's go ahead and actually perform a real site failover using SRM and XtremIO X2 and native replication. So as a reminder, this is my recovery site. I've got a consistency group here, which is in a read state, and my production consistency group is of course as a write state, and all of my VMs are currently running from the production site. As you can see, they're all powered on. It's important because once I perform a real failover, SRM will actually go on and power off these VMs. So let's go on to the Site Recovery Manager UI and actually run a real failover. I've got two modes of real failover, planned migration and disaster recovery. Planned migration is a real failover, but it can also be used as a scenario where I want to migrate VMs from site A to site B while the VMs on site A are actually up and running. So XRM will go and gracefully shut down those VMs, perform a last snapshot replication, and then try to power down these VMs at the remote site. While disaster recovery is a little bit different because it's assumed that the production site is down, it's been affected by a disaster, and therefore it shouldn't consider things like trying to power off these VMs. And even if it will, if these VMs are off or it cannot access them, it will ignore these errors and will still try to fail over the VMs at the remote site. So for the majority of the cases where you just want to use SRM as a testing mechanism but to perform a real failover, not use the test failover that we discussed in the previous demo, you are probably going to use the planned migration scenario, which is what I'm going to use now. So let's go ahead and click next. It's giving me a summary of the recovery plans, how many VMs are going to be recovered, and the fact the recovery type is planned migration. So let's click finish. Similar to test failover, what SRM will go ahead and do is make the consistency group at the recovery site writable, but unsimilarly, in the test failover scenario, the CG at the source site was still running as a write access, because remember, with the test failover, the VMs are still up and running at the production website, hence the reason why the CG and the volumes that are associated with it needs to be with the write access mode. In failover, it's different. It's actually going to transform these volumes from being write access at the source site to read access, and in the recovery site, it's going to make these volumes and change them from read to write. So let's go back to the SRM UI and see which stage are currently happening. It's probably going to shut down the VMs at the source site. There you go. As you can see from the UI, it's actually powering off the VMs at the source site. We can of course go to the web UI of the production site and see that it's actually shutting down these VMs. And indeed, these VMs are now powered off. You can actually go ahead and see if we click the VM itself and go to the data store view. We can see these VMs are powered off, and it's only that their configuration files are stored on the production placeholder data store, which again we discussed in previous slides. It's also deattaching these volumes from the production cluster that these VMs are running from, because there's no use for these volumes anymore if I'm going to fail over everything to the remote site. So let's go back to the SRM UI, and we can see that it's now in a synchronizing storage phase. So let's go to the array itself and see what it's actually doing. As you can see, because it's a planned migration and it wants to have the data as application consistent as possible, after it powered off the VMs at the source site, it's taking another snapshot, another point-in-time snapshot, in order to make sure that the data is consistent while the VMs are powered off, so there's no I/O flowing through these VMs before it's actually taking the replication snapshot. And if we go to the consistency view tab, we can actually see that these volumes are already in a write access mode. Let's go back to the Site Recovery Manager UI. Indeed, we can see that it's in this phase right now, changing the storage at the remote site to become writable. Now the switchover is already done, but these remote ES6 servers at the remote cluster needs to be aware that a new volume has been mounted to them. Hence why this operation that you see right now is happening. It's attaching these snapshots volume, the recovery volume, to the remote ES6i cluster, scanning their adapters, give them a new name if that's what we chose within the SRM advanced settings, and finally we'll power up the VMs from that remote ES6s. And indeed, if we go ahead, for example, to ES630, which is where I am right now, to its data store view, we can actually see that these volumes are mounted to it right now for the failover scenario. Okay, SRM is now powering up the VMs at the remote site. Unlike the test failover, it's actually going to use the real recovery network that we set up during the SRM configuration. As you can see, this is the real network as opposed to the PSG, the bubble, the auto network that SRM used for the test failover scenario. Okay, recovery is now completed, as you can see. As you can see, it's successful, completed successfully. We can again go ahead and export this report if that's what we want to. Now, let's take a recap of what's currently happening at the array level. At the source side, this consistency group is in read access, and at the remote side, this consistency group is now in write access. But more importantly, if we go to the data protection tab, to the session view, we can see that the replication has stopped because we just declared the failover and the recovery volumes are in a writable mode at the remote side. So how can we replicate the data back to the source side, and why isn't it happen automatically? It doesn't happen automatically because many customers, and also in real life scenarios, want to fail over the data to the remote side, and only if they're happy with the data, replicate the data back. Also in the other scenario, when a real disaster occurs, there's no array to recover the data from or to back as it were. So in order for that, there is a new feature within SRM, relatively new for the past years, that called reprotect. Reprotect is assuming that the array and the SRM and the vCenters and the ES6 and everything is up and running at the source site again, and now you want to switch the replication back from the disaster recovery site, in my case, back to the production site. So how do you invoke this? You just click the reprotect button. It gives you the, are you sure that you want to do it? Let's click yes. And next. And the only thing it's actually going to do now is try to reverse the replication back. It's still going to make the recovery site writable, but it's going to reverse the replication and start it again from the recovery site back to the production site. It's also going to update some VMX configuration files, the placeholder volume from the source site. Let's go ahead and observe this from the XtremIO UI. As you can see, the state is still inactive. Very quickly it's going to change to active, and it will also give us an ETA of how long it's actually going to make this volume writable again at the source site. See, the ETA was very quick. We can see the steps for the reverse replication directly from within the SRM UI as well. And once the session has been fully replicated, we can also click it, double click it, and you can see within the native replication UI that everything is good as before. And the actual RPO is roughly around 11 seconds, and of course the RPO that I said is 60 seconds as we showed before, so that's it, we're all done. Replication has been started again back from the recovery site to the source site, and if we go to the SRM UI, that reprotect is actually done. So now what we can go ahead and do, because we started replication, we configure the placeholders as part of the SRM reprotect mechanism, is to perform a failback. SRM doesn't call it failback. We just used to call it a reverse failover because that's exactly what you do. It's going to fail over the VMs back from their recovery site back to their production site. And in order to do it, very similar to the real failover, the only thing you need to do is click the run button, and SRM will ask you whether you want to perform plane migration or a real disaster recovery scenario. Before we actually invoke the reverse plane migration, let's look at the array pairs, and indeed we can see that now the remote site is actually replicating in a reverse way back to the production XtremIO X2 array. So again, let's go back to the recovery plan and actually invoke this failback process known as a reverse failover. So the steps are now identical to what we did in the real failover, just in a reverse way. So it's going to power off the VMs at the recovery site, perform another replication back from the recovery site to the source site, and then power up the VMs at the source site and deattach the volumes from the recovery site. So this consistency group at the recovery site will eventually become a readable one and read access mode only once replication and the VMs have started at the source site. You can now see that it's powered off the VMs at the recovery site and unmounted the volumes over there. And now it's actually doing the changing, swapping the readable consistency group with the writable one at the source site. It will of course take another XtremIO X2 snapshot to the source from the recovery site in order to make the data as consistent as possible, which is what you see here. And now it's actually doing the changing, swapping the relationship between them. The writable one will become readable and vice versa. You can now see that what used to be the recovery site, the volumes are now in a read access mode. And if we go to the source vCenter and the ES6 clusters, it's now finished rescanning the data stores over there and make them available for all the ES6 servers back again, which is what we see here. And if we go to the source XtremIO array, the one that we failed back to, we can see that this consistency group is right in a write access mode. So let's go back to the SRM UI. That's it, it's now powering up the VMs at the source side that we failed back to. There you go, you can now see the VMs are powered up, and indeed we can go and select their network setting just to see that they are actually reading their network setting from the right network switch. There you go, the same VM network switch that I had before. And that's it, recovery is complete. So if we go back to the XtremIO array, just in the first time that we did a failover scenario, if we go back to the session view, we can see that the source cluster is now indeed 1632 and the target one is 1633, just as it were on step 0 before we started with this failover demo. So what's the last piece that is missing? Well, another reprotect mechanism, which will again reprotect the data and start replication from the source array to the target array. So how to do it within SRM? In the same way that you perform the first reprotect. You just click the reprotect button. And now SRM will go ahead and start to replicate the data again, or should I say start the session again from the source array back to the recovery array, and we're back to square zero. And this is how you perform a real failover scenario and real failback scenario using VMware Site Recovery Manager and XtremIO X2 native replication. Thank you very much for watching.